All right, I believe we are live now, which is good. So this is one of the last help sessions for the assignment. I think the last one. If you're watching on YouTube, there's a link in the chat to access the Hangouts so that you can ask questions. Now, there was just something I really wanted to go through quickly before I go into people's questions. Actually, there's two things I want to go through. The first is the use of null, because people are using it inappropriately. So I'm seeing a couple of examples. As we saw in week 6, we saw that memory, something like this, and each of these spots has an address value. So let's call this address 6, address 7, address 8, address 9, address 10, address 12, and so on. None of these addresses can be null. That doesn't make sense, okay? An address cannot be null, okay? The address is a set, okay? You're not going to find an address that is null. It is always got a value. Thing red. Cute. All right. So if I have, what null is referring to is a pointer that points at nothing. So if I create, let's say, an array of ints, let's call it int pointers, and let's say it's 4 long. Now, when we draw this, we get and we have int star. Now, the pointers are currently pointing at something, okay? Something, I don't know what. All right? Okay? Question mark, question mark, question mark, question mark. However, if we don't want them to, if I want them to point at something, then I can give them an address value. So let's say int w equals 4. So I create another variable called w, and it's an int, and it's got the value 4, and I can do something like 0 equals the address of w. Okay, and so this one here will basically now point to w. However, these ones here haven't been set to anything. And what I want to do is say they don't point at anything, okay? So what I can do is go r equals null. Okay, now this one here can't point to anything because it doesn't point to anything. It is not saying the address is null, it's saying the pointer is null. The pointer doesn't point at anything. These ones that haven't been set to anything still point to stuff. If you try and read here, this will still point at something. Okay? Or it'll say thought. Now, so that's all good. Now, if I go r0 equals null, basically it gets rid of this pointer to w. And now it doesn't point at anything. Okay, so for our checkerboard example, that's probably a little bit too much. Whatever. We have Well, it does actually. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. That's right. Okay, so this is our checkerboard. Now it has a bunch of pointers and they're pointing at structs. Okay. The ones that aren't pointing at anything are null. Okay. Now, if I try and do something like, I think it's check a piece, let's go 0, 0, dash king equals something, or we test it, whatever, we access it, then that's legal because this points at a checker piece. However, if I try and do it on this second one, so I go 0, 1, then it will segfault because you're saying null king. Nothing points has a member of, which doesn't make sense, so it'll segfault. However, what will also segfault is if I try and, well, I can leave that there. If I try and access, let's say here, so I put 8, 8 in, this will also segfault, because, or it may segfault, because we're accessing something that we don't have a hold of. Now, this goes the same if you go check a piece 8, 8, not equal to null. This null is protecting us from trying to do this, going null and then trying to grab a member, but it's not protecting us from this. So if you put the wrong index in, then you will segfault. Okay? So just something to be aware of. Do not think that null means this. Okay? This is not null. This has an address. And I didn't mean to do that. Okay? Oh, for fuck's sake. That open. All right. So that's the first thing I wanted to quickly go over. I should set up layers. Right. The second thing I want to go over is for loops. Now, this should be elementary to you at this stage, but for some people, they're still having problems. Not with the for loop, but more advanced for loops, which still should be fairly simple because a for loop's been covered ad nauseam. Now, let me up the assignment. So last week in the help session, I showed how you could turn this into a piece of code. Okay, so let me. Actually, I think I had a better one. I might have deleted it actually. All right, let me do this then. Okay. All right. We have this. Now, what I said last time was, let's grab a pen. Let's jump on another layer. Go away. How do I want to do this? Can I do a custom shape? That's what I want. That's not what I wanted. I want. Right. So this here right here. Why am I making another layer? This all here could be represented as some code. Okay. Now we're left with a very simple diagram of really losing it today. We're left with a simple diagram that looks something like some code, and then it comes back up. If no, do this, else do this. Now, you should all know what that kind of diagram is. So we have loop. Yep. And you should know what kind of loop that is. Now, we've got that, so we can ignore this now. And now we need to change our shape and look at the next thing that loops back on itself. So we can cover all this. That's good. Pink. All right. So now once again, we have, I don't know why I used text before, some code here. Now, all the stuff above that, we know are looped, so we can ignore that too. So let's create another layer. Let's get some blue. Let's paint over that. Okay, so what are we looking for? Pen. So this is our first loop, loop 1. Now, we all should know what this is. This is a for loop. Okay, so we have a for loop. Now, something that surprised me didn't use a for loop because this scared them. So let's have a look at a for loop. Okay, so this is in the form that we've normally seen it, but it doesn't mean we can't change it. So this is what happens initially. This is the condition to make it continue. And this is the update. Okay?
This should be format, right?
What? What?
This should be for, right?
That's
I've
what I'm
written
saying.
if. You have written if. Maybe by mistake.
Oh, fuck. Yeah. Thank you. You're really loud. Let me turn the volume down. Okay. Thank you for that. All right. So now, so up here we have our initial, we have our condition, and we have our update. And so these two are fairly simple. For example, for layer equals something equals 1, and then we have player plus plus. Now, inside here, we can have whatever condition we like. It doesn't have to refer to player. So I could put in player equals 1. Oh, it becomes 1, and t is less than 4, and j equals 6. So it'll continue while that is true. Okay, it has nothing to do with player, but that is perfectly fine, as long as this condition is true. So if we go up to the top and have a look at this, we have is player less than 3? Is player less than 3? And both players have pieces on the board. Now, we know how to do an AND. Now we need to check both players, so it's going to be 2 ANDs. And then we check here and here. And that's it. You can put as much stuff in here as you like. Okay? And don't be afraid of it. Same here as well. So you can do player equals 1, move equals 1, etc. An initialize move. There's nothing wrong with that either. So remember, for loops, it's initial, condition, and update. And a condition can have ands in it. All right? There's nothing wrong with ands. Don't be afraid of ands. So we have a for loop. So that's our loop 2. So let's create another layer. Paint it green. All right, let's get rid of some code. All right. Now, we have a dot here. So we can basically do something like this, because we can see that there's another loop happening, and we can treat this as some code. Now, let's go for this column. All right. We know the dot refers to do-whiles, so that one's fairly easy. I've lost where we are at. I think I hid the layer I needed. Yes, I did. Damn it. Let me do this. Kill. I didn't do that. All right. So, where's my pencil? No, my pen upside down. So we have some kind of do. There. Some kind of do loop. You can put the proper words in here. You can put the proper words in here. The same goes with the other streams. In some of the other streams, some people are just copying it, where I actually say I'm being lazy and leaving things out, and people are copying just what I'm saying. And so it's a good thing, because it means that we can pick out who actually knows the stuff and is actually listening. So just be aware of that. We also have this here. So we had something after it. I'm just going to call it something. You can like what that is. Then we can get rid of this purple pinky blob. And we are left with one last what do while loop, which has some code in it. Okay. Where's the paint bucket? Okay, that's a last do while, and then there's some code there. So we have new. What's going on? What can I write? I know why. Where? Do. No, I didn't want to do that. Then we have do, then we have, give me my pen, do loop, you know what loop it is, and then we have something here. And we have a couple of somethings here, and so on. Okay, so don't be afraid of the for loop just because it has more than one condition. Okay, I've seen a lot of people writing a lot of extra code because they're afraid of the do while loop. All right. Cool. All right. That cleans my board. Do you want to start writing your questions? I go and grab some really bad code. So just right. I'm not looking at the issues. Too many things open. So you really need to join the Hangout if you want to post your questions. You don't have to speak, but just if you can post them there, it makes it easier for me. Okay, one other thing I wanted to add is this. Anyone? Oh, there's two things. Okay. Can someone type what you need to dynamically allocate something? Oh, yeah. So I know you're following along. Yeah, so you need malloc. There should only be 2 mallocs in your code. Okay? Size of is just to get the size of memory. It has nothing to do with the memory allocation. Well, loosely, it has something to do with it. If you have more than 2 mallocs, you're doing something wrong. Okay? Follow the instruction. It only asks you to create 2 variables dynamically allocated. The other thing that's really confusing me is I've seen this a little bit. So people have, let's say their function is void func struct checker piece star checkerboard board width board height. Okay, similar to the print function. Well, the same as print function. And then they have that is a function prototype. Then they, I think I've shown everyone how to do this. Oh, I think I give it in the code. So in the thing. So then we have main, blah, blah, blah. And we create our struct, checker piece, star, checkerboard, board width, board height. And then what we try and do is go func checkboard, whatever, doesn't make a difference, it's no different function anyway. Now, what is wrong with that?
You should be only passing the array, not the dimensions.
Yes. So here we have, so up here is just our function prototype. I'm just going to ignore that. But here we're creating a structure checkerboard, which is okay. So we create this and it's full of pointers. Okay, so every single one of these is a pointer to somewhere. And some of them we set null. Okay, at the moment they just point everywhere to some random spot. So if you go and read these right now, it'll probably, well, if you dereference any of these, it'll segbolt straight away. All right. Now in here, it also creates one of these at the start. So remember, this happens at the start of a function. It creates another one of these. So it sends a copy of this and we get another one. Probably should have done that as a pointer, but that would have been a little bit more confusing. So in our function, in our main, we have one of these, and in our function, we have a copy of that. Now, what you need to notice is that if I try and send this, so up here is my checkerboard. Let's say it's all good. Let's say at the moment it's initialized. This is in main. Okay, so it has a bunch of pointers pointing off to different structures, or the same structure, but still. Now, if I try and send this to my function, I'm basically saying that I want to send to my function 88, which would be this here, which is not part of your array. Okay, so I don't know what you're trying to do, but there's two problems here. So firstly, the biggest problem is that you haven't recognized that these are two different types. The second problem is that your logic, what would the function do if it only had this? It needs the whole array. So I don't want to see that. Okay. Q. All right. So one other thing that I want to do quickly. Let's just start a new layer. All right. So all right, one other thing I want to mention. Now I've lost it. Maybe I don't want to mention it. All right. So one other thing I wanted to mention is the accessing the symbols. So we set the symbols once, and there's only one set of them, and everyone seems to have done that fine now. So we have a bunch of structures. We have, and they're in an array. Sorry. We have a bunch of structures for player one, and we have a bunch of them for player two, and there's one set of symbols. One of the maybe I should do that. This one. Each one of these has a pointer as one of the members, and it points to the player one symbols or player one pieces. And then these ones all point to the same one. So this is just being efficient because we only need one set of symbols, and this will be an X, and this will be a large X, and this will be a little O, and this will be a big O. Now, to access this, we have a couple of indirections. So the first thing we have to access is our checkerboard. Now, each one of these will point to our structures. Okay, so let's say that one goes there, and then there's an enemy piece which points over here, etc. Do that in another color, just because it's starting to get messy. Okay, so we've got one level of indirection, then we have another level. Okay, so 1, 2. So to access the little symbol or the big symbol, we first need to grab the position. So what's it called? A piece, I think, and give it a value. So you may use something like I or J, or if you're super keen, you may want to set it as a number, but I wouldn't, because now we definitely should check if this is null first, but I'm assuming you've already done that. Then we have one level. So we're here now. Okay, we've only specified checker piece 2-2. Let's say this is 2-2. Okay, so we've only specified this. Okay, so we can't grab anything out of here yet because we're only here. So to get to here, we hit we need to access a member from it. So we want to access member here. So this is symbols, I think. I think I kind of fucked that up. Yeah, so we're pointing at this to access this member. Because it's a pointer, to actually go into it and grab this, we need to use this symbol. Or you can use the dot if you want to dereference it. So you could do something like that and then use a dot, which I've seen a couple of people use. It's really good. And then we need to go one more level. So we need to grab this or this. And this is a pointer. Okay? How do I know it's a pointer? Because I do. No. That wouldn't be it. Oh my god, go away. Guess it didn't embarrass him. How do I know it's a pointer? Because there's a little star there. So I know this is a pointer, and I know this is a pointer, so I need to use the little arrow rather than the dot. So if I want to grab the little symbol, then I'll just do symbol. And if I want to grab the big symbol, I'll do king symbol, I think it is. Did I call it? Yeah, king symbol. King symbol. Okay. You should only need to declare these once. Okay? So once again, if you have O, X, or X more than once in your code, you're probably doing something wrong. Okay? Some people have been sneaky and you will lose marks for it, but it will work. And checked if the player is player 2 and then printed these symbols, or if the player is 1. Now, if you have done that, leave it for now and fix it up later because it still will work, but you're wasting this variable. So either use that and get rid of this, which is a lot of work, or get rid of this. All right. Questions. I need questions. Just submit your questions. If you're in the YouTube, join the Hangout on the thing. I can't see your questions on YouTube. Okay? Just because I've got too many things open. So there's a chat in here that you can use. Okay? So click the link, join the Hangout. All right. All right. So if you want to ask a question, jump into here because I can't see the YouTube chat at the moment. Where is this on the sheet? And once you join, you may need to just mute the one. All right. Step 4 we went through last week.
I have a question. Matt?
Hello?
Hey, I have a quick question about like stage 1.
Did that just...
So once we've done all
Right,
that,
just a minute.
I still have like a lot of errors and warnings. What's the best way to go about like finding out where my issues are, like in my code, for example, like testing, I guess?
Okay, well, firstly, I would try and read the warnings and errors and
Yeah.
go through them in order.
Yeah.
The best way, I think, to get through warnings and errors is to get your code and is there any warnings that you don't know what they mean is the other thing. So don't forget Google's there to help you if you need it. However, the problem with Google, some coding questions and some errors, if they're complex errors, some people try and be smart asses and will give you the most complex answer in the world.
Yeah.
So if there's any specific errors that you're unsure of, let me know. But what's a good way to limit the amount of errors and warnings and see where they lie and what they're talking about? You can often take your code. So let's say this is your code. You got blah, 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 blah. Use this. See if this causes errors or warnings. Then move down and find out where they exist and what's causing them. Okay?
Yeah.
That's how I go about it, but I'd also read the errors and warnings. Is there any in particular that are confusing? The errors and warnings?
I think for where is it? 1 second.
If you posted something in the group chat, I may have lost it because I just lost my connection before as well.
Yeah, so one of them I get, I get it about 5 times. It says warning, single quotation, struct checker piece, and then declare inside.
Yep. So that's the warning. Wait, can you copy and paste it or send a photo of it?
Yeah, sure. I'll just copy it.
Okay. All right. So we've got. Okay. Let me have a quick look at your code just to make sure it is the reason.
So Matt, is he getting that warning just because he is while calling the function, he's sending the entire thing like struct checker piece and
No, it's not. I know the reason. All right. So the problem is that which way does the code go? Does it go up the page or down the page?
Yeah.
Down the page. So the problem you've got is that you've got, let's say, func struct A. Okay? Then
Yep.
you go after that and you go struct A int W. Can you see the problem? If code goes down the page, how does it know what struct A is if it's after it? Does that make sense?
Sort of, yeah. So could
So
you
where-
elaborate a bit more?
Okay, so it gets here and goes, what the fuck is a struct A? I have never
Yep.
seen one before. And then it keeps going and it goes, oh, struct A, I'll make one of those. But it won't go back up to the code and fix the problem before. So our function prototypes need to be where?
Below the structure definition.
Yes. Now it goes, I'll make a type called struct A, and then it gets here and goes, oh, struct A, I know that one.
Yep.
Yep. So all
That
your,
makes sense, yeah.
yeah? Cool.
Thank you.
So all your function prototypes are in the wrong place.
Yep.
Except for one. One can stay above, but I'd put them all together if I was you. All right, that was a good question, actually. Really. All right. Okay, one other thing. Why is that being silly? Segfaults. Now, with this, a lot of people are saying, I get segfaults in the print function. As long as your arrays, as long as you don't go, I is never greater than 7 and I is never less than 0, and same with j is never greater than 7 and j is less than 0. It's probably not in your print function. It's probably in your initialization function. Now, in the lectures, with the debugging one, Somnath talked about GDB, which is a general debugger, which you can use to work out where the segfault occurs. Just because initialize function doesn't do anything wrong. So let's just go back a step. So let's imagine we're in the initialize board function or whatever. So you create your board, blah 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 blah. Did I make too many? 1, 2, 3, 4. 1, 2, 3, 4. Yeah, I think. All right. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Q. Now 2 players and all their pieces, and then we initialize the board. Now, if I did it right, it looks something like, I may have done that wrong, but whatever. I have only got 6 there. That was stupid. If you did it right, it looks something like this. And each one would point to a single piece, and the other ones would be null. Yeah, and we continue along. And let's say this one's pointing off nowhere, this one's pointing off here, This one's pointing off here. This one isn't null. This one's null. This piece is pointing off to the wrong piece, etc. Is that going to cause any errors when you're setting it? Or segfaults? It shouldn't, because you're just setting everything wrong. However, when you go and access it, so now if I'm in my print function and I go, I want to print this one, and it's pointing off at some random memory address which is illegal, so you don't own it, then it's going to segfault. Where was the issue caused? In the initialization, not in the printing. The printing is grabbing each one of these. So generally, as long as your I's and J's are right and that you use null, the likelihood of your problem is going to either be here when you initialize this or when you initialize this. So in your initialization function, these could be pointing off at the wrong things. Okay? When you actually go and use them, then you get segfaults. So this is something advanced, but if you have an array and I have int star p equals malloc times 8, let's say. Yeah. Now, if I do p equals p plus 10,000, is that legal? Have a vote. Okay, let's go back a step then. Let's go back a step. All right. Before you answer that, let me go back a step. Let's say I had p equals this, and then I go p equals p plus 1. So we have p here. It's currently pointing here. And then we add 1. So now it points here. Okay, and then I do something like star p equals 4. Okay, and I change that to 4. What if I do p equals p plus 10,000? Will that cause a problem? Will that cause a segfault? Give me your guesses. Someone want to answer this?
Sorry, could you just repeat that last part? I missed what you said.
If I do this, so if I do p equals malloc, it'll point to the first element in the array, yeah?
Yeah.
Yeah, pretty simple. P equals p plus 1 with a semicolon, then it'll point to the next one. Then if I go star p equals 4, then it sets this to 4. What happens if I do p equals p plus 10,000? Will it segfault?
Yes. Will it?
Have we accessed anything?
Yeah, but it's outside of the array, isn't it?
Doesn't matter. Okay, if I do int star w, at this point it is pointing off to the moon somewhere.
Yeah.
Likely illegal. If I do p plus 10,000, this just goes off and is now pointing at some random position. Okay? However, we haven't tried to grab the value here. And as long as we don't try and grab the value, it is still legal. as soon as I do something like printf %d star p, then it'll segfault. This is where the segfault happens, not here, not in the initialization. Okay?
Yep.
So if your initialization is wrong, then your print later on is not going to work. That's the point I'm trying to get. The initialization, because we're not actually grabbing the values from it, it won't segfault. Unless you're doing something else and you are grabbing the values. Some people are. All right.
Also, thank you before. Like, I had like over 100 errors. Now I have like way less than that. So.
Can you repeat that? I'm bad.
Oh, no, I was just saying, thanks for the help before because I had like a lot of errors before. And then when I just moved the struct above, yeah, like
Yep.
most of them gone. So, yeah, thank you.
Okay, what other errors do you have?
Now I have like
Yep.
expected expression before struct. That's around where I think I'm setting up player 1 pieces and player 2 pieces.
What line?
So it says 56, line 57. So that's in the assignment. That's part, I believe. I think 3A. So in main, the dynamically allocating memory. I think that's where it says the error is happening.
3A. Okay. And it's saying what? Can you copy and paste the lines?
Yeah, I'll chuck it.
Ah, yes. Okay. This is a really good one. I think I've told you off for this already.
Oh.
So I did actually, I'm pretty sure we went over this in the lab. Okay, and you've got to remember as soon as I say it. Okay, if I have a variable, double, can I do this?
No.
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 You know exactly what I'm going to say next, yeah? If I create a struct, it is always struct dog, okay? That is the type. So if I try and do struct dog,
Yeah, that doesn't make sense.
what am I doing? It doesn't make sense.
Yeah.
Okay? Because it is the same thing as going int. It doesn't make sense. You're putting a bracket in the middle of a type name.
Yeah.
Yeah? Cool. All right. Questions? How to comparison between integer and null? You can't do an integer and you can't do a comparison between an integer and null. That doesn't make sense logically. So let's have a look at that. So the question is how to make a comparison between an integer and a null. So as I said before, if I have an int star w, now when I first create that, it points off at the moon. Okay. If I have another variable, let's say int a, I can do something like w equals address of a. So we create our A, and that's an int. Let's give it a value as well. Let's say 4. Now, when I say W equals the address of A, just be careful of my sloppy language. It's W becomes the address of A. Okay, so we've got a pointer that points there. Now, a pointer can either point at something. Okay, so I can go W equals null. And that says that it points at nothing. Okay, so see, when I first created it, it still pointed at something because I hadn't set it null. Okay. However, what would be the use of comparing 4 with null? We're comparing a number, an integer, with something that says this doesn't point at anything. A number. Is this ever going to be true?
No.
It doesn't make logical sense. So a comparison between null should always be with a pointer. So we could do something like W equals null. That would make sense. Because now we're comparing, does W not point at anything? Okay, so if you've got a comparison between you right there?
Sorry.
All right. If we have a pointer here, we're basically saying, does W point at anything? If you have an error or a warning saying, a warning comparison between integer and null, it's basically saying this comparison's pointless, and it's likely that you've dereferenced it. So if I do this, now I'm saying 4 is equal to null, which is once again pointless. Does that answer your question? Cool. Oop, what happened there? All right. Next question. Next question. Hurry.
Hey, Matt.
Yo.
Are we allowed to ask questions about the assignment?
That's the whole point of this.
Okay, no, just thought I might ask.
Except for you. Yes, of course. Go ahead.
Okay, so what's this for? So generate destination. Number 3, if the player can only move up the board, then look at the fits. Then set the value to test y.
Give me a second.
Yeah, all right.
Generate destination.
Yeah, 3. Yep. So, okay. I thought this last night. So what about, okay, they can move up. What about when they move down? So what order does dest y and dest y jump go in?
Okay.
So like, or does it really not matter?
So if we go, okay. Did you read this?
Not really.
So,
I'm being honest at least.
Okay. Being honest, make sure you read. Okay. So to read stuff, you get the page, and you look at the words, and you read it. Okay. Now let's read.
Technically, I did, but it just kind of like went.
Okay.
It just didn't
Test
absorb.
Y. A pointer to the Y destination if moving down the board, but will pass by reference back the correct destination up or down. You have defined this as jumping down the board earlier. So, if you're going up,
That's what part.
Is
That's
it-
the part that didn't get me. That I didn't get. It's like you have defined this as jumping down earlier. I'm like, what?
Yes.
What do you mean? Where?
here,
Okay. Because there's a lot of
So-
Y's, but no X's. Hardly any X's.
yes, because think about the board. So,
I've got it drawn out.
Yes,
I'm
mate.
like, I've drawn it out myself.
no, you haven't.
Yeah.
You need help.
Oh, I
Right.
need more than help. I need
So this is our
therapy. Yeah.
So, this is our board.
Got it.
I'm here. X can be
Right.
x plus 1 or x minus 1.
Yeah.
Where y can be y plus 1. It can be y plus 2. It can be y minus 1 or y minus 2. This this can be plus 2 and this can be plus 2 as well if we do a jump, but we only need to know if it's left or right. This has a couple more conditions. We could have used x, instead of using this and this, we could have done x plus 2 and y minus x minus 2 instead, but we only need to check 1.
Yeah.
Now, what this is doing, we pass in, so to our destination function, we pass in a pointer that contains a reference to you moving down the board, down with the jump, up the board, and up. But these two are pointers. Yep.
Yeah.
Now, if you go through your code and it turns out that it's up, it will turn these both into ups.
Okay.
If it's still going down, then I'll just leave them alone.
Yeah.
Yep.
Okay.
Cool.
Sure.
Cool. You happy with that?
Yeah.
Try it. Have you tried it?
Well, I still haven't finished off. That's another thing too. Is like check if the piece is at the other end of the board. If so, set the piece to king or piece king variable y. Okay.
Yep.
To check if it's at the other end of the board, I'd have to know what type of player I am. If I'm player 1 or player 2.
Easy,
And
it's
what
stored
direction?
in the struct.
Huh?
It's stored in the struct.
No, I know how to set the variable. I'm just saying, how the hell do I know which way?
You have a piece.
Yeah, not which way, but I'm just trying to think of the condition that it would have to meet. I'm trying to think of the logic.
Okay. So we could do it a couple of ways. However, don't we have? Oh, it's the wrong function. Okay, in the move piece function,
Yeah.
you actually send the player number, don't you?
Yeah. You do.
Okay, so we can do. Yeah, beautiful. So, if player 1
Uh-huh.
And what? Where's the end for player 1?
Where's the end for player 1 at the bottom? So which will be 7.
And
It'll be Y.
so
Y equals
destination-
7.
Not Y. Y was the one beforehand, remember? The destination is the one after.
So dest
Yeah.
Y.
Now, if you did a jump, this would also be different. So you need another condition. Yeah?
Okay.
Then do your king stuff.
Yeah.
Yeah? If you did a jump, then you need to test the jump one.
Okay.
Does that make sense?
Yeah. Alright. Okay. What time is lab tomorrow?
I don't know. I kind of feel like I should be sick.
Are you going to be there or not?
I don't want to be. 11.
You don't want to be.
I'm really busy at the moment. Anyways, more questions. No questions. What are you stuck on? What is stopping you? What don't you understand?
Everything.
What concept? Post your questions either with text or yep.
So, Matt, I am stuck with step 4 of move piece. I wanted to
Did you watch the
ask,
thing last
like,
week?
yeah, obviously, yeah,
Yep.
I did. So, I just wanted to ask, like, with C step, we first check if it is null, right? So, after checking that, how can we act?
One thing that
Sorry.
I don't know, if you have an if statement, and you go, what is it? Let me have a look. We are checking. Right, okay, cool. So if checker board dest y x minus 1 equals null. Not equals null, sorry. If we put an or here, if this is true, if this is false, it will just go to the next one because only one needs to be true. So you can put this in an or statement. Just letting you know that is perfectly legal. You've done Java before, so you should know that already, but just for everyone else. All right. Then we want to check cannot be reached as it is a player's piece. Now,
So, my
have-
question.
yes?
No, it's okay. Go on. No, it's okay. Go on.
So what do we have inside checkerboard? Something. We can grab, if it's a king, we can grab some other stuff. We can grab on board, which we're not actually using. We can grab number of moves, which we're actually not using. We can grab player or the symbols, which can
Something in your
either be-
throat?
Yeah. Or symbol. Which one would tell us which player it is? Ella?
Either the player or the symbols.
Well, you could actually get it off the symbols. However, that's kind of silly. I would go with player because then you have to make two comparisons.
But
So, player equals what? What's the other
we
variable
would
we
be
have?
checking with the symbols as symbols, right? So we need to check
Why?
if
Why
we have
would we
the
touch
same.
the symbols? Why?
Because we need to
Why?
check
We have
if we
to-
have the same symbol.
Why? What does
Because
it?
that's how you get to know if that is the same player or not, right?
No, we have a variable called player.
Just
What is
player. Ella, just player.
What is this? What is this for then? Why did we create this member? This will be 1 if it's player 1 and 2 if it's player 2. So we can purely say that. Yeah? The symbols should only be for printing. We shouldn't need to look at the symbols. We have if it's a king and we have what player it is. The symbols should only really be looked at when we're printing. We shouldn't need to do any comparisons with the symbols. Okay? Does that make sense, Ella?
Yeah, but anyways, you need to check like what you have diagonally,
What?
right?
I mean diagonally.
Because,
Yeah.
yeah, because that's
Which
how
is-
you're going to understand
Test
whether.
y, x minus 1. Yeah? That is diagonally. Destination y is 1 down. X minus 1 is 1 to the left. That is a diagonal.
Yes, yeah.
Yeah?
Yeah, but still I'm a bit confused. Like, if suppose I'm at certain position and I need to check what is there diagonally, then I would be checking that symbol, right?
No. You don't need to touch the symbols. The symbols are purely just there for printing. You've got the player and you've got if they're a king. You do not need any other thing for comparisons. You do not need the symbols for any of the comparisons. I should not see symbols mentioned in step 4 or 5 at all. You can do it that way, however, you're being extremely inefficient because it is redundant and you have doubled the amount of comparisons you've done. Plus, you're accessing a lot more pointers than you need to. Because you need to check, if you do it that way, you need to check, is it the king symbol? Is it the lowercase symbol? Where you can just go, no, it's player 1, so it's my own piece. It's player 2, it's the enemy's piece. Done.
Okay, I'll try.
Does that make sense?
Yeah.
Yeah, are you sure? Because
Yeah.
the player will tell you
I
which player
should try
it is.
first.
Yeah, try it first.
Yeah.
But you shouldn't, in that function, you shouldn't see symbols at all. Okay, if that gives you, so in step 4 and 5, there should not be any reference to symbols.
Okay.
Okay,
Yeah. Thanks.
that's all right. Okay, so another question was, we don't need to ask the ask user move the piece to the left or right in the main function. No, we don't ask the user to move left or right in the main function because if you watch the answer, you would have seen that if my player is here, it's not going to ask me to move left or right because I can only move right. So the only place that you should have move left or right is somewhere. Not there. Oh, no, it is there. Yeah. So if the player can move up or down, ask the direction. So that's with the king. If the player can move left or right, then ask the user for the direction. Okay, so asking the user left and right is in generate destination. Okay, does that answer your question? Any more questions?
Oh yeah, question.
Yeah.
So I'm getting this error now. Expected
You just went.
identifier.
Can you repeat it? You're very hard to hear. Can I make you louder?
Is this better?
Yeah, it tastes better.
Okay, I'm just speaking louder. All right. So the error I'm getting, expected identifier or single quotation bracket before single quotation
Token.
quickly bracket token, and that's in regards to my initialize board function. I think that's where it is.
Okay.
Yeah, I'm not really sure what that means though.
Okay. So what it is saying. Why can't I copy and paste it? Put it in here. Okay. So this is the question we got asked. Expected identifier or this before this. So what do you think it's saying? I can't actually see where it is, but I can see where it is. Okay. So this has to do with something many, many weeks ago, but what it is saying, it's expecting something before this.
Yep.
Okay. So it's saying what I'm seeing just before this. Okay. So usually the case is that you're doing something like func int w and it goes, what's this expecting before it? In a func.
Before it.
Yep. No, so remember.
It doesn't. Oh no, sorry.
So remember, everything can be expressed on one line. So before it means before it.
Yep.
So should it be expecting? Or what shouldn't it be expecting in a func? What's this? What's this?
Semicolon.
And what's it going to say to that?
That's bad.
Yeah?
It'll just ignore the square brackets.
No, because it's a function, it doesn't like it at all. It's not syntax. The syntax is wrong. So I would go to and have a look.
Yep.
Is that right?
Yeah. Thanks.
Cool. All right. So yeah, if you say something that says expected something before, sometimes that symbol is not right. But it's saying before this, there's something wrong. Okay, it should be something else. Okay.
Cool. Thanks.
All right. More questions? Shoot. Shoot. All right. We've got another question on YouTube's. So about this diagram. I think I went through it pretty well in terms of what you need. You should be able to use the diagrams from week 6 or week 7 or the lecture on flow diagrams, which I believe was last week. If you break these into loops and hide everything in between, you can easily draw this out. Remember that I think it's called a rhombus, means that you call a function. These are conditions, usually a loop. I think they're all loops. Yeah, they're all loops. So you've got the move piece function there, you've got the print board function there. So while both players have pieces, now remember at the code, you're going to have something like a global variable, which everyone did fairly right, so I don't mind pieces left or something. You can probably come up with a better name than that. So we can easily check if the player 1 pieces is greater than 0, then it means that player 1 still has pieces on the board. And I think you can work out the second one. So that's how we check how many pieces are left on the board. So this is saying that player 1 still has pieces on the board. Or if we wanted to check if player 2 does, we'll just put a 1 here. Now, just be aware, 0 is player 1, 1 is player 2. I know that we have used 1 for player 1 and 2 for player 2, but in this case, because of this array, it's 0 and 1. So just be aware of that. What else is there? This is our for loop. As I said before, this can have multiple conditions, so you can have multiple conditions in the for loop. These dots indicate that it's pretty much a do-while loop. Ask the user. We've done that since week 2, I think. Scanfs, get the values. Printf, sorry. Scanfs, get the values. Is the location null? You should be able to do that. Or the piece is not the player's piece. So if they pick a piece that's not player, once again, this goes back to what I said before. In our struct, we have player as one of the members of the struct. So we can simply go check a piece, whatever, dash player not equal to player to check if it's not the player's piece. And then is result of move equal to 1? I think you can do that comparison. It's just an integer comparison. Function just pass all these values. And you need to store the result. So don't forget, if you call a function and you want to store the result, we just write variable equals func. And we pass it a bunch of values. Q. Q, Q, Q. More questions?
Yeah, I think this question was asked just before.
Yep.
Comparison between pointer and integer warning. Could you quickly go over that again? I think it's because I'm comparing like an integer to null. I think that's why I'm having.
So did you hear why that's bad?
Because they're two different types.
Yes, so null means I don't point at anything.
Yep.
Comparing that with the number 4. It's like comparing a house with a person. Or a street address with a person's name. They're two completely different things. You can compare them, but it's not going to do anything. It's illogical. Can you tell me what one that is?
130. Oh, one sec. There's 135. Actually, I think I've edited my code.
Yep, I can see what your problem is.
Okay.
Oh, let's see other problems with your code as well. Okay. So, because you're asking a lot of questions, I'll just help you. All right. So, firstly, if I want to know it's a king, and I have checkerboard IJ, is that enough information for me to find out if it's a king?
No.
No. So in checkerboard, we have 5 members.
Yep.
Yeah? And these 5 members are king, on board, num moves, player, and then symbols.
Yep.
Now, these 2 we aren't actually using. They're just there because we're going to do some extra stuff, but need to keep the code size down. Which one do I need to which one do I need to use to work out if it's a king?
Player.
Which one of these 3 do I need to use to work out if it's a king?
Oh, symbol. Symbols.
The one called king.
Oh, sorry, king.
So,
No, I was just thinking king is a symbol. I don't know.
King.
Yeah.
yeah?
Yeah.
Comparing checkerboard, which is a pointer, with, let's say, the letter Y, which is also a number. Does that make sense?
Yeah, kind of. So if I assign like a macro king to Y, is that what you're saying?
Okay, no, stop. So we're comparing a pointer with a number.
Yeah.
So I'm going address 48 equals 2. Does that make sense?
Yeah.
They're 2 different types. Doesn't make sense. So what we need to do is say checkerboard, and we need a value. So checkerboard king equals Y or n.
Okay.
Because now it's not a pointer because we've dereferenced it using that arrow.
Yeah.
Now we can make a comparison between an integer and an integer. Now, just a warning, when the compiler says integer, it is referring to an actual integer. So integer is a car, an int, a short, and a long.
Yep.
Okay? An int doesn't mean integer. Well, it sort of does, but it sort of doesn't. All these are integers.
Okay.
Okay? Because by definition, they're all integers. That they're all numbers that aren't real. If it says real, it's referring to float or double. Okay? So just be aware, just because it says integer doesn't mean it's not talking about a car.
Yeah, makes sense.
But yeah, now I'm comparing a number.
Yeah. So
This
just
has a
set the
Y or an N in it.
dereference-
With what?
So I just had to dereference my checkerboard because he didn't know what I wanted to compare to. Yeah.
Can you repeat that?
So my issue before was just my program didn't know
I can't hear you
What?
properly.
my checkerboard was comparing because I wanted to find like if it was king, but because I didn't specify it with my checkerboard, that's why it didn't.
Sorry,
Anyway,
I really can't hear you properly. What's
Don't worry. Forget that question.
Okay. All right. Another thing that I wanted to add is in my code, should I ever see this by itself? What's it missing?
Symbol?
Yeah. Now, another thing that's wrong is that if I need the symbols, it's not player symbols, it's symbols by itself. The name of the variable is symbols. Okay, so when you grab the symbols, it's always going to be checkerboard, IJ, symbols. That is the name of the variable. Okay, we don't say int. Yeah, we say the name of the variable. So symbols, and then I don't know, king symbol. Yeah.
Yeah.
That's,
Yeah, makes sense.
which I believe you actually had right, and then you changed it.
Yeah, I think I did. I had it commented out before. Yeah.
Huh?
I think I had it just commented out before. Yeah. Thanks.
Yeah. But the line was wrong, but the way you were accessing it was right. All right. I think I'm going to have a smoker break. And I want questions by the time I get back. Some good questions. Excellent questions. Super excellent questions. All right. Any more questions? Are we all good?
You've got my. Can you just bring my code up in front of you if you got it? If you got it in front of you, if you get access, please.
Yeah, got it in front of me.
Yeah. Going back to move piece 4. I know I haven't moved past this, unfortunately, but I just want to be clear. So I'm assuming that for every bit that is not set, we are going to set it. So we check if it's not set, and that's what we're going to set.
Yeah.
So
you
say like move flags. So we test move flags bit 0,
Yeah.
right? And then we do the check, and that's the bit we're going to set, so on and so forth, from bit 0 to bit 4.
Yep.
Sorry, yeah. Bit
However,
1, bit 1, bit 3, bit 4. Sorry. You did point out, and I know I read your comment. You did point out that my checks have got to accommodate for the directions that I have to go. Now I know that the first two bits is for going up, and the last two
Right,
bits is going down.
Let's get through it.
I've drew out a thing in front of me, so therefore, if anything is left and down, x cannot be less than 0, and y cannot be greater than 7.
Give me a sec. Let's print screen. Print screen.
Print screen.
Yeah, I'm gonna copy and paste the. Quality.
Optimize.
Look at that high res. Why did I do that? Okay. So in what am I doing?
Baby poo.
There it is. Okay. So in move pace function,
Yes.
we have a bunch of variables. So choose a piece. And I'm going to actually do something. I'm going to move you here, and let's make and all right. So the piece I'm looking at is going to be this one here.
Yeah.
All right. So let's go through this. I have no clue what I'm doing. Right. So we have dest y.
Yep.
Y jump. We have dest y2. We have dest y2 jump. We have dest x. And we have dest x jump. So initially, so we're doing it from 0. So this is 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7.
Yep.
1, 2, 3, 4, 5, 6, 7.
Yep.
So just y is 5. Dist y jump is
Can you just
6.
draw the axes, please?
Yeah.
Because I'm getting confused.
Okay, so this is y.
Uh-huh.
And this is x.
It's x. Okay. Thanks.
Okay. So this here is dest y.
Yep.
This here is dest y
Jump.
jump.
Yep.
Then we have dest y2, which is minus. So we have 3. And then we have 2. Correct? So dest y2. Dest y2 is there. And dest y2 jump is there.
Yep.
And x we don't need to initialize.
Yep.
So our bit flags. Ugh. What am I doing? These a bit smaller. They're still readable, yeah.
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 Oh.
I can't. Okay. And now, what I want to do is I got anything like that. Cool. All right. So now I want to look at my bit flags. So bit 0 says that I can't move. So not
down.
left and down.
Yep.
Bit 1 says not right and down.
Yep.
Bit 2 says not left and up. And bit 3 says not right and up. So the first thing that I check is
Bit 0.
is it a king?
Oh, yeah. Yes.
Is it a king? No, it's not. So that's fine. So then we check what player it is. So if blah, 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 player 1, then we know it can only move down. So we know these two have to be set to 1.
Okay.
Okay, so we can just do something like what's the variable called? I don't know what we call it. Move flags. So move flags.
Can I just ask something quickly?
Now. Yep.
When you go if, do you check the checkerboard at y and x?
What do you mean?
Is that what we're checking? Is that where we're checking? At y and x?
Yes.
Okay.
Yes, y and x.
Y and x. Okay. Because I wasn't too sure if we were supposed to be doing
Well, this is the piece at the moment.
Okay, yeah.
So y is currently 4 and x is currently 5. So
okay.
Y and x.
And it's always y and x. So y first and x.
Yep. If you do it completely opposite, as long as you've done it completely opposite throughout the game, it shouldn't make a difference.
Okay.
Because the board's 8 by 8.
Yeah.
If everything's inverted, it still should work.
Yep.
All right. So because it's player 1, we set bit 2 and 3 to a 1.
Mm-hmm.
So these are now 1s. Okay. So now from there.
Oh, I didn't check the x and y for player 1 and player. I just checked what was actually called by the function. Or were we supposed to check the piece if it was player 1's or player?
Oh, no, you don't need to. You can just go because you got that player variable.
Yeah.
You don't really need that player variable. It's just I don't know why it's there. So if player 1,
that's
then
what it was there for.
Yeah. Yeah, you don't actually need it, but all right. So we've got that. Now I just want to do one other thing. Fuck off. Move that across. Cool. All right. So now we want to check all our bit flags.
Mm-hmm.
So the first one, so the last two we don't need to set because so we can first go if bit 0 is 0.
Yep.
Then we do something.
Yep.
Obviously, don't write it like that.
No. It's just pseudocode.
So we are looking at left and down. So
Yes.
left is x minus 1, And
Yep.
down is dest y and dest y jump. Yeah? So these are the things we're looking at.
Didn't use test
So-
Y. Oh, yeah, I did use test Y jump. Yeah.
So the first thing we need to check, destination of x cannot be left as x minus 1 is out of bounds. So that is checking if it's here, which would
Yes.
be x negative 1.
Yeah.
So we can basically say if x minus 1 equals negative 1, then it would fail.
Yeah.
Then, or something, then we need to check it can't be down as dest y is out of bounds. So dest y for down out of bounds is going to be 8. So dest y equal 8. Or the destination cannot be reached as it is a player's piece. So this is something I went through before.
Yes.
I'm gonna
Which
write
I've got that. Yeah, that's fine.
Or the destination y and x minus 1 has an opponent's piece. Which it does, actually. Oh, no, it doesn't. That's right. That's left. That's right. So we just check, does this one have an opponent's piece? So is it the other player? And be careful of those brackets. And the jump destination can't be reached. So what that's saying is basically if we are here, not here, or here, it can't jump because it goes out of bounds, or there's something in the way. So this is in the way, or your own piece is in the way, etc. So that's can't jump. Okay. Now, for the next one, everywhere it says x minus 1,
Yep.
we are now looking at x plus 1. Yeah? So everywhere we have x minus 1, we need to change it with x plus 1. And we need to change this comparison. What's out of bounds on the...
So it's going to be greater than 7 or greater than 8.
Or 8.
Greater than 7.
Yeah, greater than 7 or equal to 8. Either one will work. Or dest y equals 8. Because dest y is still going down. So we only need to change this x plus 1.
That's right, yeah.
Now, in the third case, we're going left again. So it's going to be x minus 1 again. We have x plus 1. So what else do we have in the third case? We're not using dest y and dest y jump anymore. We're using dest y2 and dest y2 jump. So all of them need to change to dest y2, and all of these ones need to change to dest y2 and dest y2 jump. Because we're going up the board now. So everything is, so once you get this one and you work out how to do these two parts, it's just a copy and paste. And this one, you just change the x plus 1. And then in this one, you just change this, this, and this. Just change this, this, and this. Does that make sense?
Yeah. Cool.
So once you've worked it out, it's pretty much copy and paste and just changing these.
Yep.
Heal.
Me it is.
Now I need to find the chat window again. Cool. No questions. No questions. Tell them, Alex.
Yeah.
Cool. So you got no errors or warnings now?
Yeah. I figured
Does it
that out.
print out the board?
Yeah.
Does it print out the board?
No. Oh no, because I didn't call the function in main.
Ah.
Yeah.
Come
Yeah.
on.
Here we go.
Do it.
Right, I'll do it now.
Oh, wait. Is this yours? I'm going to kill you. Okay. So this is something I said right at the start.
Yeah.
Right at the start. Right at the start. Okay. If I'm a function and I had to print out the board,
Yeah.
and all this checkerboard had been initialized properly and it was pointing at the right things. Okay, so it's pointing at the right things.
Yep.
Yep. What would I want to send to the function? So we can think this as checkerboard array.
The array of pointers.
Well, you want to send the whole array, yeah? The whole big array, yeah? You want to send the whole checkerboard.
Yeah.
So, explain to me why. So this is the pointer that points to the start of the array. And that's what we send around to have access to the whole array, yeah?
Yeah.
Yeah. So, why are you sending this? So you're sending checkerboard 8 to 8. Yeah?
Yeah.
I don't want checkerboard 8 8. I want this pointer that points to the start of it. What's that called?
Pointer?
No, it's just called checkerboard. Yeah? So remember with our arrays, int w4. Now the notation I use is specifically for this point purpose and to emphasize this point. What do I send to a function if I want to send the whole array?
There was a question.
If I want to send the whole array, W, what do I send? You've got three choices.
See?
C. Bingo. So, what should we send here? CB?
Name of, yeah, CB.
Yeah.
Okay.
Okay.
Makes sense, yeah. Thanks. Yeah, because I just thought, because having 8 8 is like the size of the array, that would do like the whole thing.
Yeah, but you're indexing it now. So remember, after we've initialized, so this is the thing that you really need to remember. And this is the thing about C. So remember int star W and star W mean, the stars mean something completely different. Yeah? Because this is an initialization and this is an expression. Yeah? So this one's dereferencing, and this one's creating a pointer. Yep. The same goes with arrays. If I have int w4 and I have w3, this one is creating the array. And I shouldn't say initialization there, I should say declaring. I'm being lazy, and I'll say declaring there as well. This is declaring it. This is indexing it. So after I've created it, I should never see this 4 ever again.
Yep.
Because what's it refer? That. Because that's index 4.
Yep.
Yeah?
Yep.
Same here. Okay, it's the index. So with your exam practice, make sure you know the difference between declaring and using. Okay?
Yep.
Cool.
Awesome.
Sure. Did you just update it? Want me to refresh it?
Yeah. I was compiling now.
Oh no, it's the question in chat. Cool. Which one is it? Complete, one, or fix? Fix. All right. Okay, where's the comments? This one's interesting. Yes. You fixed it, but you still can optimize it. So you've got an interesting one. It's still going to work. So I'm not going to bother too much about it. But I might do an example because it's a really good example. But so do you understand what was wrong? Because I don't have to explain that, but I might explain what you've got wrong right now, just in terms of optimizing. Okay. So I'm just going to explain something that someone had as part of their code. So I'll do it with a different type. So we have a function called func, and it accepts a int star. Okay, and it returns void. Then we go into main, and then we have our void func int star. Let's call it W. Just for fun. I don't know why I've used W so much this time. All right, cool. So in our, what I'm going to do, just make everything a little smaller. A bit more space. Move that up. All right. So this is kind of an interesting one. I was kind of found it interesting. So I want to send a pointer here for something. So I create an int called W. Yeah, it's called W. And I set it to the value 4. Then what I do is I create an int pointer called Z, and then I go int star size of int star. So then I go equals the address of W. Then I go func Z. Now, what I call this is a hack. Okay, so this is trying to get around the fact that you're trying to guess how to get into this function rather than really understanding it. Which I see a lot of, except for this is the most interesting one. Because what most people do is just try a whole heap of symbols. What you see a lot of in some solutions is people will go func star hashtag W int whatever until it works. Okay, so this is quite an interesting way to get around it, except for there's something really bad here. Okay, there's one thing that will still work, but it's poorly coded. But there's one thing really bad. This. Yeah. I don't want clone, I want that. This is really bad for multiple reasons. Okay, so go away, Robert. Right, so create W of type int, and we set it to 4. Then we create Z, which is an int star, and then we malloc another int star, which is nameless, so we have to free it. We then return a pointer, so this is pointing at this. The first thing you will notice, it is pointing to the wrong type. You've said int star, it should be pointing at an int. So this is already wrong, and it will treat this as an int. Then you go Z equals the address of W. So now you're pointing it here. Now it's extra dangerous because we can never find this address ever again. We couldn't. And so we can never free this memory because we have no name to it. Okay? So if you malloc something, you need to free it, and you shouldn't overwrite it. If you're going to overwrite it, you need to store address here. But there's two things wrong here. You're pointing at the wrong type, so it should be an int. And secondly, you go, fuck it, I'm just going to look at the other one. So let's get rid of that. So instead what I'm going to do is I'm going to have the address of W here. So now we've got rid of the line. Okay. So now we've just skipped this step of making some scary, very scary, dangerous thing. And we're saying, I want W and Z, and they're in main. And then I call this function. So in this function, we create a pointer. I might change the name of this and I'll call it X actually. X, and it's of type int star, and it copies the value from Z. So it grabs this value and points at W. Now, what can I do to improve this code? Can someone tell me? Just use Z. I think you mean the opposite. Just use W. So see how X is pointing at W? So why don't we just say the address of W? Get rid of that. Because Z is not doing anything. And we've still got a pointer here. So it will still work. It's just a variable sitting here. Z is doing nothing. Make sense? Cool. That's not as big of a deal. That if you had that, I'm not going to care as much. But the statement beforehand, where you had the malloc, that's really okay. If you want to do this, if you want to do this just to help with your understanding or something, it's inefficient and it's poor coding, but I'm happy with that if you want to do that. But the malloc thing, no. So while I'm here, yes. 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 Now another thing, and this goes back to what we were talking right at the start. You shouldn't need at all. When you do this, there is actually no if statements here. There is not one if statement if you do this correctly. Okay? As you can see, everything loops back. So everything is a loop. Okay? So I notice you've got that problem. I did go through it before. This is your while loop. This part here is your for loop. These three are your for loop. This is a do while. This is another do while loop. Okay, you shouldn't have an if statement. It should just be for loops. And I showed how you can block out stuff so you can simplify it and see what's inside each of those loops. Okay. But yeah, I did that right at the start of the video. I don't know if you were there. Anyone got any questions? Conceptualize continue jumping. Okay. I'm not giving too much help with continue jumping just because it is meant to be the challenge. And quite a number of people have already got it. So I will give a conceptual version though. Actually, no, I think so. Yeah, what I'll do is give me 2 seconds. What is that? That's 8. Good. Sorry, I'm just making a board. I can use this a little easier. I wonder if I can just copy and paste this. I can. Beautiful. Alright, so there's my board. Let me grab the instruction sequence. Do this the right way. Alright. So, oh, that's not what I want. Alright, so what I want is to conceptualize continue jumping. And I'm going to do it. Yeah, that's better. Right. Okay, that's a nice looking board. All right. So let's say, let's go a different way. Go away. A circle here. And I have an X here, an X here, and an X here. So continue jumping means that I will jump once, which you should be able to do, and then I end up here. Now, if I can, I'm allowed to continue jumping if there is a free place to jump. So because there is a piece to jump, spot here, then I can continue jumping. Once I get here, I see that there's another place I can go. So that is another continue, and then it becomes the king. Okay? If it becomes a king, it can't continue jumping on that move. So even if there's a piece here, it can't go back and jump it. The king can go any direction, up or down, but once it's kinged, it has to wait a move and then it can jump again. Now, alternatively, there's a whole bunch of conditions for this. Let's say there's an X here and an X here. So then I get jump over this piece and I end up here. I have two options. So now I need to ask, would you like to move left or right? And then I can choose which one to jump, okay? If there was, say, a X here, an X here, and an X here, then it would go jump, jump, because it can't jump that one. If there was an X here, then it would jump once and go, I can't move anymore. Now, it gets better. So if they're a king, so let's say we have a king. No, not a good spot. Yeah, kind of here. I think. So let's say, what the hell I can go? Let's say it's a king. Okay, so it can move up, down, left, right, all over the place. So, for example, let's say there's an X here. Let's say there's another X here. Let's say there's an X here. Let's say there's an X here. Let's say there's an X here. Actually, if I go, yeah, that's a pretty good example. Okay. So, and this is where this would be the test to see if you've done continue jumping right. So, if I want to move this one, it's going to ask me, should I move up or down, or left or right? I have 3 options to jump here, and I could go up here if I wanted. And the official rules, you have to jump. So I choose to go right and down. So I go to here. It's a king, so it can keep jumping. So it would go here. Then it can continue jumping. So it would go here. Then it can continue jumping. So it would go back to the start. And then it can continue jumping. And it can go here. And so it's just taken 5 pieces. So with the king, you can get some pretty complex moves happening in the continue jumping. However, because we've treated all the pieces as knowing where it would go if it was a king, that's why we calculate dest y and dest y2, is so that it makes it easier when we do the king. It shouldn't be too hard to implement. I think most people got stuck on how to set the king when you reach a multiple jump, but most of these people have worked it out now. Does that make sense, Antonio?
I'm considering even if it's worth freaking doing at this point.
So it isn't that difficult. It's pretty much very similar to move piece, except for 2 things. The first one is that if you get here, you need to check, can I jump again, but not care about the condition where I can move here. So it's less conditions for your bits. So you're only checking if you can jump, rather than can you move here, can you move here, is there a piece in the way, blah, blah, blah. You're only checking if it can jump with your bits. The other difference is that you just add recursion or iteration. And that's the only difference. So it's pretty much a copy paste of that, except for you need to change all your bit flags so it only looks at jump.
So it's just a while true. If it's as long as it's a while true, then it will just keep on checking where it's going to jump next. Essentially.
Give it a go. It isn't much further, but you just need to understand what conditions relate to jumping and which ones don't. And also how to finish the function if it becomes a king at the end. Which is actually easier than you think. A lot of people wrote a whole heap of code, but it's actually 0 lines.
A lot of wrote 0 lines.
Right. A lot of people wrote a lot of code, but to actually do it is 0 lines of code. So, yeah.
To do it is actually 0 lines of code?
Yes.
Huh?
Hmm.
Ah.
They wrote too much. because you check king in your move piece function anyway, and then we're doing it twice. So you shouldn't.
I think I know what you mean. Yeah.
All right,
But even still. Also, another thing too is I've re-uploaded. So if you want, just have a look what I've done, see if that helped.
No.
Works. Oh, not so much works. Like that I can test, but I can't test it until most of the other stuff is done.
Wait a minute. Oh, okay. That's okay. I have 2 windows. Just doing something. Sure. There's some really nice solutions. What am I looking at?
The setting the bits, move flags.
I think you put something wrong in all of them.
Oh, that's just handy.
I'll check something. This one. Says radios line. A mistake through all of them. So your mistake.
Even if you just make a note, a written note, or you can tell me verbally, one of the two.
The mistake is in this one. This one exactly.
What one? Write down.
Wait. Oh, wait, I'm looking at marker. wait, it looks right. No, all of them. All the bits, that step you've done wrong.
All the bits or that step I've done wrong.
The one that's highlighted.
Okay. That.
Yeah.
Cannot be reached or null. Okay.
That. Maybe that.
I'll have a look at it.
It's a very quick fix. The word jump might help.
For all of them.
Yeah.
That jump
You're
destination.
missing something. I should update it. I'm not looking at the right one.
I got dest wide jump at the very end.
Yeah, I know. That's this one. Jump destination here.
If that dest.
You're looking at that one. How many get? About that one. It's 2 conditions back.
2 conditions back. next to the end.
Mm.
What?
Is that not that?
The destination.
The destination or the jump destination?
The jump destination. What's the jump destination?
Dest Y jump. Or Dest Y2 jump.
Is it really?
Oh yeah. Is it really?
The jump destination cannot be reached because it's not null. Oh,
Yeah? Really obvious.
light bulb.
So this is... All right. Any other questions? Or should we wrap up?
I think I'm good.
We are.
You had a question.
Yes.
What was it? Yep. So I get an error saying player 1 undeclared and player 2 undeclared inside my main function, which I think that's referring to my initialized board.
That's an interesting one.
Yeah.
Can you copy the error?
Yeah. One sec. Let me send it to you.
Ah, yes. You're right. You're completely right.
Yeah.
Yeah. Just one other thing before I say anything. Antonio, fix your spelling.
Why? What did I do wrong?
It's not how you spell pieces.
Pisces?
Yes. So Alex,
Yeah.
what variable has your player 1 pieces in it? Is it called player 1? Or is it called something else? In main. Remember the scope
Player 1
is...
piece.
Huh?
So
Pardon?
my player 1 pieces.
Yeah. So shouldn't it be player 1
Oh.
pieces, player 2 pieces? Because in main, that's what's in scope. Okay?
Yeah. Sorry. I looked. Yeah. Yeah. Okay.
So just because the name is different in initialized board doesn't mean it's the same in main. They're two different variables. But you pass them to make it generic. It's like when you pass the 1, it turns into player number in the other function because it's a different scope.
Okay. That makes sense.
I want to see your board printed.
I'll give this a run.
I'm going to look through Antonio's spelling.
Again with the spelling.
Spell variable wrong. Spell contains wrong. He spelled board wrong. Spelled congratulations wrong.
Really?
Spelled struck wrong in one of the comments.
Come on, please work.
I did too.
Spelled anywhere. He spelled anywhere wrong in one of the comments. He spelled return wrong in one of the comments. He
Oh my
spelled prompt
God.
wrong in one of the comments.
What is
Take it
this?
easy.
Mine is so ugly.
Huh?
My table is so wrong. It just doesn't look right. Like what's inside the table, I mean.
Your table doesn't look right.
Yeah.
Why? It's just out of line.
Yeah, out of line and
Yeah. You've got extra spaces in random places.
yeah.
You've got one extra space every line, I think.
Yeah, maybe that's why it's going over.
So,
Where did I make the wrong spelling of board?
give me 2 seconds. It's it. What's it? That's it. What's it? Line 72. In the comment.
That's correct. BOARD.
You fixed it.
No, I didn't.
And in line 89, you've got BOAORD.
Ah, that one.
I see it in 2 places. And congratulations is written wrong.
I fixed that now.
Cool.
Ah, I see it, yeah.
Did you say where the extra space is, Alex?
Who are you talking to?
Alex. I'm talking to you. So you should have something
It's a
that's
bit
like,
wonky.
yeah. So remember, for each one of these, there is 3 spots. Okay.
Yeah.
Yeah, and then a line. So you've done the one with the line correctly. So you got 3 spaces.
Yeah.
When you do the C, you go star% C, which is 1. That's 4.
Yeah.
That's 3.
Yeah.
I should fix up most of the spelling mistakes.
Thanks.
Sure, you did.
I knew I shouldn't have freaking studied for that other test. Should have just kept on coding.
What spelling?
No, I should have just kept on coding instead of freaking studying for another test. I was had like my code focus, and then it's all like screwed up.
You never stop coding.
Huh?
Never. You never stop coding. Also, I wrote a program yesterday. I fixed it up. I did post an hour yesterday. Got rid of it. To generate examples for box and pointer diagrams. So I'll generate like 100 or so, and you can practice them. Just questions, just code. Code that generates code.
Okay, that generates code. Self-authoring code, huh?
Yep. So I'll put up, a whole bunch of things, a whole heap of examples that you can play with that are similar to the one we did in practice with the box and pointer. I'll do like 100 or maybe 200 or 1,000 or whatever. Generate as many as you need. 10,000. I'm not getting more so close, but the board is half printed. I don't know who you are, so I can put your code. You don't have to let me know who you are, but know your code, because half printing and no clue what's going on.
What are you talking about?
Someone put a comment.
Oh,
The tubes.
the tubes.
Tubes. Beep. Emotions. I think we're pretty good. Okay. Is there any more questions? I don't know who I am for time. So board print out, Alex. Right.
It looks alright, just not what's inside.
What do you mean?
Like it's not giving me how do I explain it?
The pieces?
Printing zeros.
I mean, all
Oh
of
no,
them.
it's printing. Oh, it's printing the capital zeros at the top and then capital X's like at the bottom. I don't know how to explain. But like the X's are on the far left of the screen.
Okay.
I've uploaded a new copy of my assignment. Like I don't know how to explain. It just it doesn't look right.
Okay. That's quite interesting.
Yeah.
Hmm. 3,000 Kelvin or 5,700 Kelvin?
7.
7. 1,000 or just 7?
7.
Hmm.
That's right.
Don't understand why people put fucking cool lights.
Because they're cool.
Ugh, so sterile.
Is this a new version? You didn't get rid of that space, did you?
I think I did, didn't I? Hmm.
Ooh, it is very ugly.
Yeah.
That. Okay. What's happening? Ah! Yeah, I see what the problem is. Okay. So let's go have a look through some of the logic of your for loop. So you have 4, 4, 4, I equals 0, I less than 8, I plus plus. Then you have a line with the number. Yeah?
Yeah.
I'm not going to write the full code out, so don't give it out. And then you have j equals 0,
Yeah.
j less than 8, j plus plus. Then in here,
Yep.
you print out the symbols, out a new line, and then you print out a whole heap of lines and dashes. Yeah? But that's not in a for loop. Yeah?
Yeah.
So, why is there a fly? All right, so you print out a 1 when you get here. Then you print out a symbol. So let's say the symbol is. Then you print out a new line. So you get the next line, and then you print out a big line. Can you see what the problem is already? Where should these two go? After every symbol is printed?
Yep.
You want to print out a line after every symbol is printed?
What do you mean a new line? No.
Where do you
I
want to do
go
that?
new line after I've done
All 8.
all 8. Yeah.
So where should this go then?
Outside the for loop.
Well, that's not outside. Well, outside one of the for loops, not the outer for loop, because we want to print how many lines? We want to print 8 of these.
Outside of the inner for loop.
Yes.
Yeah.
And get this. Let's see. Sweet. Yeah, you do have capitals.
Yeah.
Yes. Because of something. Why do you have capitals? So the other thing is that you've got, %C and then 2 spaces. It should only be 1 space. But why do you have capitals?
1 space after C. Okay.
Yeah.
Yeah.
Oh, king is Y as well. Remember how we initialize them all to N? Because
Yeah.
they're not king yet. So your macros are wrong.
Yeah. Okay.
Should be the other way around. And then you should get something that looks like that. Beautiful. Okay. We got There's many more people left.
Awesome. Thanks. Yeah.
All right. And it all works?
Yeah. It works. Cool.
Looks good? You got the lowercase symbols?
Yeah, looks good. Yeah, lowercase symbols. Yeah.
Cool. Now you got to do stage 2. So save a copy of that. Save a copy of that.
Yeah.
And then start stage 2. So you can always go back to safe space. Yeah. So you follow what I said before about the loops. Don't use if statements.
Yep.
And yeah, it should be fine.
Awesome.
All
Thanks.
right. We might finish up there.
No worries. You got to practice for the 24-hour check.